When we're graphing linear inequalities, it's kind of a combo of two things. What we're going to do is we are going to take a linear function. Again, it has the word line right in it. We're going to draw a line, okay? Normal old graphing lines. And the only difference is going to be now, instead of just drawing a line to find answers, the solutions that we get are going to be shaded on the coordinate plane. We get to do a little coloring here. So when we graph, for example, here, this line, and I'm going to actually put the dots on the line they've actually graphed so we can see how this works. So just a couple of quick reminders. We're always going to graph the y-intercept first here on the y-axis, and it says that's 1. So there it is. And then the second part of our things is always going to be our slope. And slopes always rise over run. So if my slope is -3/2, and the negative's only on one number, not on both, that top number tells us if we're going up or down. The bottom on the number tells us if we're going left or right. So you're like 1, 2, 3, 1, 2. 2, 3, 1, 2. You can see my dots are on there. If I happen to have run out of room before I can make extra dots, you absolutely are able to switch the signs and put the negative down below, where you could go up 1, 2, 3, and left 1, 2. And I end up in the same place. So there's where my line came from. Now, the thing with these, and I'm not going to go too crazy yet because we're going to have to chat about how we determine what the line's going to look like, but we're going to figure out what side based on your arrow. So I'm going to keep quiet about that for a minute. We'll revisit how the shading part when we actually work this through here in a second, but I wanted to make sure we were good on the line part. Okay, slope-intercept form, plot the y-intercept. We just talked about that. Use your slope to plot the other points. So here's our example. My y-intercept is -4. So there's my first dot. If your slope is not a fraction, I suggest making it 1. So you're not just like going up 3 and putting another dot. So in this case, we'd go up 3 because it's positive, like it was there. We're going to go 1 right because it's also positive. So 1, 2, 3, 1. But here's where inequalities are different from regular lines. What type of arrow you have is going to determine what type of line you're going to draw through here. So if it's just less than or equal, no, excuse me, nope, less than or greater than, there I spitted it out, we would use a dotted line or a dashed line, it's called sometimes, or something like that. But if it's or equal to, less than or greater than, like ours is here, that's going to be a solid line. So this one, we're drawing it through solid like we normally would. So that's the first part. The second part then is the shading. Now this is where it gets a little more interesting. I'm going to tuck y's in here ahead of these, because when you're trying to figure out if it says greater than or less than, it all has to do with y. Okay? If the arrow is eating y, if y is greater than, we're going to shade above the line. Okay? We're going to shade where the positive y-axis part is. If y is less than or equal to, the arrow's pointing at y, we're going to shade below. So for this particular one, we're going to be shading above. And I always tell people, if you're looking above, I find the top of the y-axis where that arrow is, and that's the side where I'm going to shade. So that's why even in the one up here, y is greater than or equal to, there's the greater than side. That's why we were shading above. And we will see one here momentarily where it's less than, so we can figure out the below part. But those are the two main things we got to remember. What type of line, and where am I going to be shading? But they even got to throw twists on here again. These mathematicians, I don't know what they're doing sometimes, why they got to make all these twists to things. If we're in standard form, okay, standard form looks something like this. Okay, definitely not y equals, definitely not y on a side by itself. So if it is, we want to get it in y equals form first. And then we just follow the steps we just did. So here, my whole goal is to get that y term by itself. Now we've been doing this already when we've been solving our inequalities. So we're going to do opposites on everything. Opposite of positive 2x. Be careful though, these are not like terms. This has x, this doesn't. Don't smash them together and call it 6x. That will not work. And ooh, man, this is rough on a first day of the week for me to ask, but I'm going to do it anyway. What do I need to do when I'm dividing everything by a negative? It's flip time. So that arrow flips. Also be cautious. It's a simple thing. Our brains can play tricks on us sometimes. You might look at that and you might think it's 4 divided by 2 and 2, but it's not. Oh, it's not. That's 1/2 positive. And 8 divided by negative 4 is negative 2. So that's what we're going to be graphing. So once I've gotten there, there's my y-intercept hanging out on the end. Everything's positive with my slope. So positive is up, positive is right, up and right. We like to get at least 3 dots to make sure things are going okay. But now we're ready for our 2 questions. Am I going to be putting a solid or a dotted line through here? Dotted, because we just have the greater than. We do not have the or equal to. So we're going to go dotted. And are we going to be above or below the line? Above, because y is greater than. So there's the top side of our y, and we're good to go. So as we start to get down here to the bottom, I did one of each, because again, with this, with the twists that we can run into, it can be a little interesting trying to figure out, you know, how everything goes. So let me do this. I'm going to freeze frame for a moment here, maybe. Okay, there we go. So try to graph these, watching out for what type of line and where you're shading. And then we will get back together here in just a moment. And we'll see if we're running into any issues before we add one last piece to our puzzle. And if you're watching later, pause me and try it yourself. Let's see here. So, okay. Couple things to mention. So we've got y is greater than negative 1/2 x plus 2. Again, our y-intercept's at 2. The negative only goes on one of the numbers. It does not matter which way you go. If you put it on the top, we go down 1 and right 2. We get a couple points. If you put it down here in the denominator, we go up 1 and left 2. So we'd have those. We're dotted. and we're shading above where the top of our y-axis is. The second one is like this one here. We're going to go ahead, 4x out of there, divide by 5. No flipping this time. We're not dividing everything by a negative. So my y-intercept ends up at 4, and then we're going to go down 4 and right 5. That's the only thing we could do. The other one would be off the chart. Solid line. And since y is less than, since the arrow's pointing at y, we're going to shade to the bottom half, or where the y is going down or less in value, down there. But normally above and below is pretty straightforward. It would end up making things a little bit easier for us. Okay? Any questions or issues before we add one more slight twist in, because then we'll wrap up here. Drop water on everything. Okay. So let's put one more piece in here. Oh, Hardy, we got to do the applications, don't we? Yeah. I mean, this is an application-based course, so yeah, we got to get the application in. So, same keywords that we've seen before for the different parts. Yeah, greater than, more, above, below, okay. Maximum, at most. Maximum and minimum you talk a lot in a business sense with, so that wouldn't be a bad thing to have either. So let's kind of look at the forms here and see what we can do with these. Mateo charges a flat fee of $15. Okay, so that's just regular old 15. Tarek leaves plus an additional $4 per hour. Anything that talks about multiple, is it 1 hour, is it 3 hours, is it 5 hours, I don't know, gets an X. If he works at least 6 hours, he might work 6, he might work more. How much will he make? Okay, so let's see here. So 4 times per hour plus 15. And we've got the greater than part. You're like, okay, Hardy, where's the 6? What's the dealio here? Okay, so the fee and the per hour, that's going to create my equation. But if he works at least 6 hours, that's where this is going to come in. That's going to be the number I'm going to plug in here. So if I look at that, I'm like, all right, let's plug this in. Let's put this over here. I'll take this back down in just a sec. So actually, believe it or not, I have 2 coordinate points I have right now to make my graph out of. So let me explain where those come from. One of my coordinate points is right here. What number did I plug in for X? What number did I get out for Y? So that's one of them. My other coordinate point comes from just plotting my y-intercept. So here, my y-intercept, if I'm plotting a point, the x value is 0, but I've got this 15. So I have another point right here. That's technically all I need to be able to make a line. Since it's or equal to, we're going to have a solid line connecting them. And since it's greater than, we're going to shade all the parts above. Now, how does this help me as far as an application goes? Because now I would be able to look, since I have this information, and know exactly, okay, what's the minimum amount I'm going to be making for each portion all the way up. Like I have an exact number, but I can start figuring out, well, if I work this long, how much am I going to make not wait. Hopefully I won't wait when I'm doing this. And start trying to figure out I get at least that much money. So those are going to be the two ways I can get my points, no matter what form I'm in. So for instance, let's play with another, because this is kind of weird. Isaac wants to buy 5 hot dogs and 4 hamburgers. Okay, we got 2 variables here. I'm going to call my hot dogs X, because we have an XY, and I also see here the hot dogs are on the X-axis. That might help me a little bit too. And 4 hamburgers, the hamburgers are my Y-axis. So we're buying 5 hot dogs and 4 hamburgers. Okay. He spends less than $24.50. So not less than or equal to. So we've got that. So here comes my first equation. But we want to know the intercept. So we're going to go ahead. We're going to get this solved for. So we can graph this, or at least graph the intercept. I think I'm even going to need a little bit of calculator help here. So if you're not sure on something, so let's say that slope. Whoa, calculator's going to die. Let's see how far I can go before it decides to die on me. Okay, so that stays as -5/4.
What about, isn't it supposed to be -4?
Here, you mean?
No, for the Y.
This one?
Yeah.
If I'm buying and getting both of them, I'd want to make sure I get them. They're not taking 4 hamburgers from me.
But it wouldn't cancel out either way. It would just, right?
It's dividing, not subtracting.
This 4, you mean?
Yes.
Okay. So this 4 determines on the positive or negative based on this. Since that was plus 4y, this is still positive, so I'm still going to divide by +4. And since we're talking about money, since that didn't come out to a normal cent, we're going to go to the nearest cent here. So with this, my coordinate point would be just over 6 and 0 for that first point. So whenever we get the equation that we're looking for, we're going to steal the y-intercept from it, and that's always going to be 0. But for the other part, they give us a little more info. If a hot dog costs $2.50, so if my x value is $2.50, what's the cost of a hamburger? Okay, so let's see here. So everything else stayed the same. The only thing that we have that we don't know now is y, the hamburger part. So let's do a little work here. All right, let's minus that 1250 over. And then divide by 4. And so when x, a hot dog, is $2.50, at most the hamburger is going to be $3. So $2.50. So a little past 2, right in between 2 and 4 there. And since it's just less than, we're going to be dotted. Less than, we're going to be shading under. So that would let Isaac know all the possible combinations of buying hamburgers and hot dogs he could do with the amount of money that he has. Like he'd be okay buying 2 hamburgers and 2 hot dogs, 4 hamburgers and no hot dogs, anything in here would work. But it just kind of lets us know what a couple of the limits are. All right, one last one. Because again, we got to let the weird ones have their day here. So I'm gonna freeze it for a second. I'm not gonna do it real long. I want you to try and set up the initial equation on your own. And if something gets stuck, don't worry about it. No problem. All right. Ooh, now that's gonna be interesting. All right. The tricky thing on this one is we talk about how normally a word like per ticket, every something is going to mean you put an X with it. And you're like, well, wait a minute. Does that mean the 10 gets an X and the 3 gets an X? Which would be sensible, as you can see. I started to write 10X, but then I had to look at it. I'm like, well, wait a minute. I go up to a movie theater, they charge me $10 to get in. Oh, that's like my admission fee. So that's just going to be 10. Okay. But the number of concession stand items I buy, that can vary. Maybe I buy popcorn and a soda. Okay, that would make something that changes the value. So there I had to get around the idea that per had to be X and get myself to this. If I want to buy at most, that would be less than or equal to. So I got my initial equation, my 3x plus 10, y is less than or equal to that. There's my y-intercept, 10. So I've got one of my 2 points that I need to make my graph. Then we're talking about 5 concession items, okay? That 5 is my x value. So I'm going to plug that in for x. I'm going to figure that out. And once I get the y value, I have my x, I have my y, I have my 2 points to make my solid line. Because it's or equal to, and since it's less than, we're going to be shading underneath when we look at those. So these will pop back up at a little bit later of a date. I wanted to get you an intro to them. But our main focus today is going to be the graphing and shading part. Because sometimes you can get way too many things going at once, and that gets a little too complicated. So here's our goal. So here, we're going to deal in the practice part with pages 29 and 30. Again, we're basically just going with the basic graphing of inequalities. Now, I do want to do one of these because it's a little strange. I shouldn't say it's strange. It's asking a question in a different way. Write an inequality for the graphed line in slope-intercept form. Okay. So to be able to do this in slope-intercept form, I need to know the y-intercept. I need to know the slope. So I start looking. I'm like, okay, there's my y-intercept. So up 2. So I'm going to have plus 2 for my b part. Well, what about slope? I need to find another point on my graph that goes through the little crosshairs, I like to call them. But they go right through the middle. Like notice here, they're kind of going through the middle of a couple lines, don't really care. But if they're going through those crosshairs, that's where I can count So I can look now and I can say, okay, so if I'm going, I go up 1, and I'm going right, 1, 2, 3. So my slope would be 1/3 with my x. I've got my y here, and it looks like I shaded above, which is greater than. Okay, if it's above, we're greater than. If it's below, we're less than. And since it's dotted, I don't want to put a line underneath it. So it's kind of me working this backwards. They give me the answer, they want to know what the question is. And so that happens on a couple of these. So I wanted you to be aware. But otherwise, we're just working on the graph and shade, get it into the right form, and doing it